Scholars spent 30 years certain they knew who built ancient Israel. One DNA lab just changed everything. In 2023, a resequenced genome forced a museum to redesign the face of Otzi the Iceman. His skin darker, his ancestry rewritten. If a single mummy could be that wrong for that long, what happens when the same molecular lens turns toward the Bible's most foundational origin story? In September 1991, hikers in the Otzi Alps discovered a naturally mummified body frozen in the ice. This was Otzi, a man who lived over 5,000 years ago. For decades, he was a premier archaeological celebrity, his physical appearance reconstructed in detailed museum displays. When a multinational team published his first draft genome in 2012, the results seemed to confirm a familiar picture: a light-skinned, hairy ancestor with genetic ties to migrations from the eastern steppes. But that profile was fundamentally flawed. The original analysis suffered from nearly 10% modern European DNA contamination, introduced during laboratory handling. It was not until a team led by K. Wang and Johannes Krause published a high-coverage resequencing in Cell Genomics that the error became clear. By utilizing cleanroom protocols that reduced contamination to under 1%, the new data revealed a vastly different individual. This man possessed dark skin, brown eyes, and male pattern baldness, carrying over 82% Anatolian farmer ancestry with no step signature whatsoever. At the South Tyrol Museum of Archaeology, administrators had to retire the iconic light-skinned bust. It was a clinical demonstration of how easily modern proxies can distort the ancient past when direct molecular evidence is compromised. In the mid-20th century, biblical archaeologist William Albright established a dominant scholarly approach that treated material culture as a direct indicator of ancient human migration. When excavators uncovered thousands of distinctive, heavy-rimmed storage vessels, known as collared-rim jars, alongside standardized four-room houses dating to approximately 1200 BCE, they did not view these findings as simple technological developments. Instead, Albright and his contemporaries read these objects as the diagnostic fingerprints of an entirely new population arriving in the rugged central highlands of Canaan. The sudden appearance of these rustic settlement patterns, contrasting sharply with the sophisticated urban material culture of the Bronze Age lowlands, was interpreted as a clean cultural break. The underlying logic of this school of thought was straightforward. A dramatic shift in pottery and architecture must have been driven by a biological break in ancestry. Under this model, the physical objects left in the soil were read as ethnic markers, the material proof of a migratory conquest that brought the early Israelites into the land. For decades, this artifact-based consensus formed the foundation of biblical history, operating on the firm assumption that a change in everyday tools always signaled a change in the genes of the people who made them. Just as the 2023 correction of the Tyrolean Iceman forced a physical rebuild of a museum display, Highland archaeology is experiencing a similar methodological shift. For decades, researchers mapped the roughly 250 Highland settlements identified in surveys by Israel Finkelstein, attributing them to a new ethnic population based solely on pottery style. To challenge this traditional reliance on material typology, geneticists collaborating with the Reich Lab bypassed ceramic shapes entirely, replacing subjective typology with genome-wide sampling. By extracting DNA directly from ancient skeletal remains, scientists can now analyze millions of genetic markers to map real biological ancestry, rather than relying on archaeological guesswork. Finkelstein historically interpreted this sudden Highland expansion as a distinct cultural footprint, though he recognized that pottery is an imperfect proxy for genes. As excavation practices move from ethnic attribution by objects toward direct ancestry testing, the standards of proof have changed. Ultimately, molecular evidence can overturn confident artifact-based assumptions when sampling and contamination are controlled. In 2020, geneticists Iadawan Harney, Iosif Lazaridis, and their colleagues published a landmark study in the journal Cell, analyzing a genome-wide dataset of more than 100 ancient individuals from the southern Levant. They examined the biological foundations of the region's history. The data challenged the older, artifact-based model of sudden migration-driven replacement in the Iron Age highlands. Instead, the skeletal remains of populations archaeologically associated with early Israelites showed overwhelming genetic continuity with the Bronze Age Canaanites who came before them. A smaller Eastern ancestry component, originating near the Zagros Mountains, did appear in these Iron Age genomes, but the researchers found this signature was already present in older, pre-Iron Age layers. Because of this, the Eastern genetic marker does not represent a new, distinct Iron Age arrival. A 2022 study in Current Biology confirmed that genetic differences between inland and coastal populations tracked local geography rather than a conquest-driven ethnic replacement. The biological lineage did not break. It persisted. To test whether ancient DNA analysis is sensitive enough to capture migration where it truly occurred, researchers turned to the ancient coastal port of Ashkelon. In 2019, a study published in Science Advances analyzed genomes from a Philistine cemetery. The results showed a genetic shift at the beginning of the Iron Age. The early Iron Age burials contained a European-related ancestry signal, averaging roughly 39%, that was completely absent from the local Bronze Age population that preceded them. Within a few generations, local intermarriage diluted this genetic signature, blending it into the broader Levantine population. This rapid fading shows how quickly a founding migrant signal can disappear. More importantly, it establishes a methodological control. Because genomic tools successfully detected this fleeting coastal migration, the complete lack of a similar genetic disruption in the Central Highlands carries genuine historical weight. This genetic continuity does not disprove the biblical exodus, nor does it rule out a small founding group. A tiny band of newcomers, absorbed into a larger local population, would leave only an invisible molecular trace. More importantly, ancient genomes cannot settle theological questions of identity. Who the Israelites were was defined by culture and daily practice, separate from biological ancestry. Archaeologist Avraham Faust argues that early Israelite identity was constructed through active boundary marking. This is visible in the physical remains of what these people ate. While coastal Philistine sites contain abundant pig bones, sometimes exceeding 30% of the animal remains, contemporaneous highland settlements show near-total pig avoidance. For these highland clans, identity was forged through daily taboos and shared rituals, creating a cultural boundary that genetic sequencing alone cannot map. The Eastern genetic signature found in these ancient genomes extends the historical horizon thousands of years before the Iron Age. This Zagros-related ancestry, present in the Levant since the 4th millennium BCE, reveals deep, continuous migrations between the Tigris-Euphrates Valley and the Mediterranean coast. These genetic ties do not validate the specific historical journey of Abraham. However, they establish that the biblical memories locating Israel's ancestral roots in Mesopotamian centers like Ur and Haran were framed within a world of genuine, long-term regional migration, preserving a biological echo of a highly connected ancient Near East. The rapid restructuring of European prehistory between 2010 and 2015 showed how ancient genomes quickly upend traditional archaeological models. Now, a similar acceleration is occurring in the southern Levant, with new site-specific genetic studies published every 12 to 18 months. The Tel Megiddo Archaeogenomics project is actively expanding the Iron Age sample record from biblically relevant locations. When direct genetic data replaces ceramic typologies, clean narratives of migration or conquest often fracture, as ancient human origins prove far more complex than physical artifacts alone suggest. Ancient DNA does not erase history. It reveals a deeper, local continuity. The true origin of a culture is rarely a sudden invasion, but a quiet evolution of identity. As molecular science advances, we must look beyond physical borders to understand who we are. Join the conversation below.